Life safety issues exist. Emergency repairs required before restoration to make ready for intended use. Failed with major repairs. Technical repair report for bidding. Restoration with permit by fully licensed vendor. Engineer oversight. 3 site visits. Certification with owner liability in lieu of a load test. Load test still may be required by the AHJ.
Fire escape engineers, inspector summary. This is Inspector Gabe. I'm out here in 405 Main Street. This is in Houston, Texas. It's a pre-load test examination determining the current state of this fire escape system, which also has a standpipe system connected to it, as you can see there. And access to the FDC is made out of the first floor, grade level down there. So as you can see, fire escapes, 2 things. Fire escapes must be structurally sound. Fire escapes must be kept painted. So you see there, fire escape is in desperate need of a paint job. As you can see, it's filled with surface rust all over. You need to scrape that and repaint it and add some silicone to prevent any water penetration to the connections. Second, structural connections. This fire escape is in desperate need of a full refurb. As you can see, all it has is original hardware by the form of rivets there. Has some original hardware by the form of hex head bolts. Square bolts. You want to replace those and add some hex head bolts, newer hardware. As you can see, some of these connections are filled with rust, and some of it already became affected so much that it even made a hole into this connection there. As you can see, you got some surface rust and also internal rust. And for example, here I left the tape measure to determine how much of rust jacking has this fire escape been subject to so far. As you can see, it's more than an inch of rust, so that explains at least 75 to 100-year-old rust. Never been maintained, shows no evidence of maintenance from all floors. Now, access to this fire escape was quite difficult due to life safety concerns of those connections there holding this fixed ladder in place are suspect. Therefore, I decided not to use this fixed ladder to access the other floors. As you can see, the grating filled with rust jack all over. So this is a 6th floor platform. It's a 10-story building. Has a lot of companies or a lot of firms that reside on this building. Access to the fire escape is made out of the window, and as you can see, there's children and workers performing their own work, daily duties. So this fire escape does contain lead. It is a pre-1978, so it's presumed to have lead. So painting this fire escape will require an EPA's renovator license for lead abatement. You need to encapsulate this fire escape while you scrape and paint the fire escape and not allow any of the lead to go into the building. As you can see, Inspector summary. This is Inspector Game performing a fire escape inspection. So as you can see, this connection here, the structural connection holding the fixed ladder to the standpipe system and also the railing systems contain rust jacking. To be exact, it has internal rust jacking, which makes the connection suspect. Due to the high risk, I decided not to use this fire escape to work my way up and down these platforms. As you can see, now on the 2nd floor platform, that's where I saw the majority of the structural concerns, the major life safety concerns. needing emergency repairs. Now at this point, fire department cannot access this fire escape because of its current state, which is in a state of collapse. Nor can occupants use it because this ladder here has a chain holding it shut. So even if occupants evacuate towards the platforms and work their way down, before they reach grade, they will stop at the second floor platform. At that point, the fixed ladder is chained, linked together, so therefore it won't go to grade. So let alone that alone, it's a code violation. Evacuees and occupants need to evacuate and safely work their way to a grade level. Currently, that's not possible because the fixed ladder is shut in place. As you can see, this is some punch through rungs here, bars. You'll use this to climb the fire escape, and this is a structural connection here, original hardware. As you can see, you want to go ahead and pop those bolts and introduce new hardware, new hex head bolts. And you want to silicone shut the connections here and on the top. That will prevent any water penetration, would indeed prevent any internal rust jacking affecting the structural connections. This is Inspector Gabe. I'm signing out of the 6th floor platform. I will start recording when I get access to another floor. Thank you very much. Fire escape engineers, Inspector Summary. Resuming fire escape inspection, 405 Main Street, Houston, Texas. I'm here at the 7th floor platform. As you can see, all floors have a fire protection system, which is known as a standpipe system. Fire department comes and hooks up their fire hose, which then supplies water to the interior fire sprinkler system. Now, fire escapes must be contained, fire escape must be structurally sound. As you can see, the entire fire escape lacks a coat of paint. As you can see, it contains surface rust, and some of the connections have internal rust. So, for example, it needs structural work. Some of the railing connections into the building, which are brick here, it's suspect. There's internal rust inside that connection. There's also some cracks, masonry cracks happening around this connection. So we want to go ahead and investigate that furthermore. As you can see, we also want to verify the railing connections into the building. Rust jacking occurring, surface rust, some areas internal. So as you can see there, it has some internal rust accumulating there. Original hardware, all it has is square head bolts, and some areas are riveted together. The fixed ladder has some punch through rungs. However, rust has taken a heavy toll on this fire escape. Moving on to the grading, as you can see, surface rust all over. Original square head bolts there. Heavy surface rust occurring. And in some areas, rust jacking. For example, we got some internal rust area there, and also has some cement issues, such as this connection, the railing connections. Now, in terms of the platform grading here, you see some rust jacking accumulating there, and already we see the internal rust jacking taking a toll. It has accumulated for far too long that it has actually moved and created a space in between these two sets of grading here. So for example, you see that little spacing in there, and here you cannot no longer see through because there's internal rust jacking accumulating. Now that's anywhere from 1/2 inch to 1 inch of rust As you can see, the fire escapes, every platform has that problem, specifically with its two sets of grating here. However, some areas are more severe than others, but this one here already has ½ inch to an inch already of internal rust jack. And that's what I meant by some areas becoming internal and suspect. Now this fixed ladder is secured to that fire escape and fire escape platform and the actual standpipe system. You want to go ahead and repair any of the internal rust, clean that area, prime and paint. After that, you want to silicone shut the connections to prevent any water penetration from causing rust jacking, as we see all around this fire escape. Inspector summary. Inspector Gabe signing out, second floor platform. Fire escape engineers, inspector summary, resuming fire escape inspection. I am now in the 11th floor of this fire escape system, the highest platform before you head to the roof. And I'll show you now what I'm talking about regarding a gooseneck ladder to the roof. As you can see, original hardware connected, filled with internal and surface rust. Punch through rungs into this fixed ladder. It has structural connection here, and as you can see, it appears that these bolts are undersized hex head bolts. This is the only instance where I see new evidence of strength, and in this case it would be the hex head bolts, as you can see there. Now the only problem is that there's still some internal rust taking a toll in this connection, as you can see there. Also, this one I took a picture. There's a gap in between one part of the fixed ladder and the other part of the other side of the fixed ladder. This one does have a rivet to hold it in place, and it has a square head bolt. So this here is the only evidence of strength. However, as you can see, this bolt is already rusted out as well, and it has internal rust. And going up, punch through rungs in this ladder connected to the standpipe system that also goes all the way to the roof. Due to security concerns and also hazard, I am not gonna climb this to reach the roof, so I'm just gonna talk about it, making sure that I address some of the structural connections there. As you can see, it's taking a heavy toll in terms of the surface rust occurring, and it has internal already as well. So this is the gooseneck ladder that goes to the roof. It's very in an inclined position. You would have to try to climb via the adjacent side, which is very, very dangerous given that it has no fall prevention of any sort or like a secured cage around it. So it would be very, very difficult for fire department personnel to make their way up to the roof. Now, this ladder is not meant for evacuation, but it is meant for fire department access, gaining roof access via this fire escape here. So you want to verify the connections through the wall. Make sure that those through bolts are well connected and well situated with the wall. There should be a plate in the other side of this brick veneer. Sorry, it wouldn't be veneer, it would be actual brick, which will be further verified based on investigative work. So as you can see here, fire escape must be kept painted, fire escape must be structurally sound. At this point, it fails both aspects given that it hasn't been painted. Throughout the fire escape, we have heavy evidence of rust jack from surface to internal. Now, some of these connections are ranging anywhere from 75 to 100 years old. For example, these connections here, square head bolts, are original hardware. Never seen any kind of maintenance, never seen any swap out. At a minimum, every 25 years, all bolts shall be swapped and changed with new hex head bolts. Here you want to scrape and paint. You want to prime the area to prevent any rust from accumulating in the future. And then you want to silicone shut the connections. That way you'll prevent any water penetration from working their way inside the connections. Fire escape engineers resuming the fire escape inspection. As you can see here, it has some structural work suspect here in this connection. And now we see a little bit of the stonework here being compromised, so you can see water could accumulate inside, which it already has, and you see a little bit of rust jacking occurring there. You want to verify that connection that tied back into the building. So as you can see, in terms of the grading, original hardware there, surface rust all over. This would be some rod bars here. There is not major issue with this rods here holding the grading in place, except for the fact that it has a lot of surface rust. If it doesn't get taken care of, it'll soon become internal and jeopardize the integrity of this grading system. Now, in some instances, in some sections, you see heavy rust jacking. For example, there, some metal needs to be replaced, and now you're still having maybe you have enough meat to save the fire escape after a full refurbishment. That would entail replacing any and all structural connections with new hardware in lieu of a load test. Now, this is a pre-load test examination. We're not telling you how many problems it has, but we are noting some of the areas of concern. Fire escape must be kept painted. Fire escape must be structurally sound. I'm here at the 11th floor platform, the highest platform before reaching the roof area, as you can see here. Now, access to this fire escape from all floors is made through intervening rooms, so you actually have to have permission or access to go through an intervening room. For example, the majority of them are like law offices and that kind of tenants, and they have no clue regarding some of the fire escape status here. So some of this fire escape is already in a state of collapse. This is the fixed ladder that goes through every single floor. As you can see, some of the connections here are suspect. By all means, is surface rust and internal rust taking a heavy toll on the majority of this connection. So that explains why I didn't access all floors. Some of the floors are vacant and locked, and some of the floors are windows are also locked. So I was only able to access the fire escape via some floors, as you will see in the video. So as you can see here, we got some original hardwood bolts and rivets. You want to go ahead and swap those out with original hardware, introduce some new evidence of strength. As you can see here, we have a 1/4 to a 1/2 inch of rust already accumulating, so that might be anywhere from 25 to 50 year accumulation, and that's because of water penetration getting in between the connection and not going anywhere and just causing some oxidizing the metal here, taking a heavy toll on it. So you want to go ahead and clean that out. You want to scrape, prime, and then paint this. Once all that happens, you want to silicone shut the connections with anywhere from 25 to 50 year silicone, prevent any water penetration from working their way in. Fire escape engineers, Inspector Summary, Inspector Gates signing out. I will now record when I'm at the grade level, looking up to the fire escape. This is Fire Escape Engineers, Inspector Summary, Inspector Gate. Fire Escape Engineers, Inspector Summary. Accounting for some of some in bad condition in terms of the grading. As you can see, we have some severe rust. It became internal, and that it even ate the metal flats that are underneath this grading system. As you can see, that piece of metal needs to be replaced. We have some rust jacking occurring in between the connections. Original hardware in the form of square head bolts. No evidence of maintenance, as you can see. Original hardware. If you don't take care of the internal rust, the surface rust, it will eventually lead to internal rust, which is what will kill this fire escape system in terms of its structural integrity. As you can see, the standpipe system connection is shoddy, therefore that needs to be replaced to introduce with new structural connections with new hex head bolts. Fire escape engineers, inspector summary, noting some of the severe case of rust jacking. Inspector Gabe signing out. Fire escape engineers, inspector summary. This is Inspector Gabe. I'm here at 405 Main Street. As you can see there, this is in Houston, Texas. I am now at grade level. After I went up this fire escape, I went all the way to the top 11th floor, which has a gooseneck ladder to the roof. It also has a standpipe system connected to every floor. So not only is it meant for evacuation in case of an emergency, serving as a secondary means of egress for occupants residing inside this building, but also is being used for fire department access to each floor to be able to support the sprinkler system via the standpipe system. As you can see, it's well located. FDC fire department connection. There goes my sticker where I tagged this fire escape system. The results: life safety concern, failed with life safety concerns. That's the inspection determination for today. I will be developing the report with further information, further details regarding what exactly failed. Now this is a preload test evaluation. 866-649-0333. Fire escape engine.
Life safety issues exist. Emergency repairs required before restoration to make ready for intended use. Fire escape issues. Photos represent what the violations are, not where they are or how many exist. Pass-fail inspection, not technical repair report.